Hello interwebs, welcome to Let's Fix Computers. I've got a MacBook Air here which does not power on. We have no green light on the charger, or no orange light, no light whatsoever. So that means that we are missing some primary, main, super important power rails. So let's take the bottom cover off and have a look. So I'll buzz out the 10 screws from the bottom. There's an odd coating over this thing that looks like a very fine vinyl wrap or something like that to cover up a load of scratches or something. Not sure why, but if you're wondering why there's loads of weird looking markings on it, yeah, that's what that is. No idea why that's there. Oh, that's interesting. It's spray paint. And I tell you how I know that, because it's gone all up the inside. How bizarre. Fine. We're missing a screw from there as well. It's been disassembled before because this screw is scratched up. So, okay. Let's see, what do we have? I'm just going to take off the bridge and just inspect that. Right, I've unplugged the battery and plugged in the charger. Let's check for some basic voltages. I'm guessing we're not going to have PP3V42 because that powers the light on the charger. So we kind of need that. That'll do. Right, is PP3V42 on this side? I don't think it is. Let's check for it over here. 19 volts in, and there is PP3V42 at the source, so that is there. Okay. What about PP bus G3 hot? Have we got that? Okay. Right, PP bus G3 hot. This tells us a bit more. That is at 8.2 volts, which is wrong. That should be 8.6. What this tells me is that the SMC is not running because PP Bus G3 Hot will run at 8.2 or 8.18, and then when the SMC switch is on, it bumps it up to 8.6. So from this, we can determine that the SMC is not working. And that is also why we don't have a light on the charger, because the SMC controls that light. So what we'll do now is I'm going to take the logic board out of this thing, and I'm going to see what we find on the other side of the board. Given that we've got just spray paint on this thing, I'm concerned about what's on the other side of the board. Let's take it apart. Alright, so again, we've got this line of silver along the back. It hasn't strayed too far onto the logic board. I don't think that's done any damage. I don't think this is the cause of our problem, at the very least. I'm going to plug this back in just to check if there's been any change by removing the motherboard from the laptop. There has not. I might grab a different DC in board as well, just to make sure I'm not getting punked by a bad DC in board. Because if this guy's not working properly, then that might be causing our issue. And that might cause the SMC not to turn on, which means you have nothing. So I'm going to swap out the DC board just in case. Alright, different DC board. Bam. Yeah, same thing. Okay. Fine. Why doesn't our SMC turn on? So let's pull up a schematic for this and we'll just check some obvious things. So this is a 820.00165, and if I zoom down to the corner here, there's a section down here, and this is SMC reset. And what this chip does is it tells the SMC if it should turn on or not, basically. So it sends the on-off signal, the reset signal, that kind of thing. So what I want to know is the SMC being told to switch on, or is it in a reset state? Is there some other reason why it's not turning on, or is it just busted? So I'll put my multimeter into voltage mode again. And let's just see what I want to probe. So firstly, SMC reset L is the first one I want to check. So SMC reset, if a device is in reset, it means it is resetting. So a reset signal is a momentary signal. It's like the reset button on your PC. When you press it, you momentarily contact that switch and then release it again. While the switch is in, while the button is in, the computer is in a reset state. And then when you release it, it comes out of a reset state and begins to boot up again. So in this case, SMC reset underscore L, the L means low. So it means when this signal is low, a la 0, we are in a reset state, as if we're holding down the reset button. So we want to see a signal here. So I'll put my black probe on a screw hole for ground, and I want to check pin 5. It's going to be a little bit awkward to get in there. Let's see if we can probe that guy. And there's 1.2 volts there. I'm not sure if that's correct or not. I was expecting 3.3 volts. What is powering this chip? This chip is powered by PP3V42. Let's make sure that it's getting 3.42 volts. That might be correct. You know, it might just be 1.2 is the high state. I was just expecting 3.42 volts because that's normally a 3.42 or 3.3 is normally the true signal state for a MacBook. I believe, anyway. Okay, that's fine. What about SMC on-off L? What state is that in? So that's pin 7. The guy goes over to this big old pad here. That is high. Okay, where does SMC reset come from? It's got a pin over at JTAG over here, which got spray painted. Can't believe that that's our issue. I'm going to look up the schematic for this to find out how SMC reset is created, because I'm not sure. Okay, yeah, that's confirmed. The U5110 does create SMC reset L. And also this line, it should be, I was correct, it should be at 3.42 volts, because here we have a line pulling it up. This is called a pull-up resistor. So it's a 100k resistor, and what this does is it's got PP3V42 coming on onto this via this resistor. So because this resistor connection is here, in a normal condition, SMC reset L should be at 3.42 volts. And then when we want to reset the SMC, this chip will pull this to ground. Now you might say, well, if that grounds it, doesn't that create a short circuit? It doesn't, because of the resistor. Because there's a 100k resistor there, when you short this to ground, it cannot go short circuit because there's 100k of resistance to the power line. So this goes to ground, but the pull-up line does not, which is why it's not a short circuit. So that's why when chips are sending signals to each other, they can just short something to ground because the natural state is going through a pull-up resistor. So this confirms that our reset should be at 3.42 volts. So we need to find out why it's not, because I think that's our problem. 1.2 volts, it's not zero, but that's probably low enough to be interpreted as a reset state. So we need to find out why. So what else is on that same SMC reset line? So we had the JTAG connector, and we've got a test point all the way up here. Is that even visible? No, it's not. Okay, what's on the other side of the board? Then on the other side of the board, there's a resistor over here going to... What's that? I can't remember what the U7100 is. It looks like charger management. And then we've got the actual SMC itself, which is the U5000. So there's not a huge amount on here. Let's start with the simple one. Let's take U5110 off the board and see if SMC reset goes high. Now, we won't be able to turn on with this thing off the board because there'll be nothing to tell the SMC to turn on. But what we need to do is just see if that pull-up resistor then pulls up to 3.42 volts. So let's see if I'm lucky and it's that simple. Because I was kind of hoping that there wouldn't be a lot more on that line, but there's a couple of things, and yeah. Right, chip removed. So I'm just going to give the board a second to cool down. We have a green light on the charger. And was that fan spin? It shouldn't start. Yeah, that's what I thought. Good, okay. I was going to say we should be quite unable to turn on at the moment because the chip that tells the SMC to turn on is not there. However, it looks like we have a culprit. There we go. So SMC reset L is now up at 3.38. So it's supposed to be 3.42, but probing and stuff like that. That line should be 3.42, but because I'm trying to poke it with tiny little probe points and there's losses in the wires and all the rest of it, you'll never see exactly the right voltage. But that's clearly supposed to be 3.42. Fine. So U5110 is dead. And that seems to be partially shorted to ground. It's not a full short to ground. However, it was certainly dying enough that it was half pulling down that line. So theoretically, if I can find another one, we can just stick another one on the board and we're laughing. So I'm going to check my breaker boards and see what I've got. This board's a bit grubby around that area. However, I've no reason to believe that this one doesn't work. We'll soon find out. No, that's really not coming clean. Fine, whatever. Hot air and flux will boil it all clean. Purity is coming. Ah. That came off concerningly easily. And for orientation, the dot is in the bottom right of the chip. And that is pin 1. So I'll just put that on the board there for a sec. And if I check the schematic, we'll find pin 1 is indeed in the bottom right. And we'll just touch up these solder joins before we put this back on, just so we get a decent connection. Part of me is very tempted just to put the same chip back on the board, just for testing. I might do that because it's not uncommon to have just a chip that's just developed a cracked solder joint or a dry joint. And it's interesting to test for that because sometimes you don't actually have to replace the part, and if you just happen to not have a spare, then that's suddenly going to be very interesting. So I'll actually put the old one back on first, just for the sake of testing. Alright, that goes back on. Let's just see what happens now. If you've got replacements, then I would recommend using them anyway, I think. Just in case you've got an intermittent part, but I'm interested in doing this for testing. We have a green light and we have fan spin. And the fan continues to spin because we've actually switched on now. There you go, folks. Didn't even need the spare. Good stuff. All right. Well, I'm going to put the old one back on my donor board then, just so it's still there. And then we'll put this back together again. So this one turned out to be easier than it looked. However, cracking example of SMC Reset L in action, or rather not in action. And also a great example that you might not need to replace the bit that you've taken off. As I say, that's not necessarily the recommended action, but I know certainly for people who are starting out in board repair, you probably don't have a load of breaker boards lying around. And when you don't have... Heck, I need some flux on here. I was trying to be lazy. There we go. When you don't have all the spare bits lying around, suddenly very simple problems can be very difficult to deal with because you've got to spend 3 weeks waiting for a bit to show up from China every time you make a move. Which is a heckin' pain in the ass. Ask me how I know. Right, I don't need this to be on properly, I just need it to be on. That should do. As long as it doesn't fall off. There we go. Good. So I wonder if that was the spray paint that's eaten away at that, or whether that's just a coincidence. Either way, don't spray paint your laptops in this manner. If you're going to spray paint something, actually take it apart and strip it down first. And this doesn't happen. What a bizarro issue. There we go. That looks fine to me. Let's put it back in the laptop. Reassembly is the worst bit, because this is the point where you're just like, I've won, I've done it, can I go and do something else now? Actually, I'll rephrase that. The worst bit is reassembly after you've given up. Because you have to put the laptop back together again, because you can't just give it back to the customer in a pile of pieces. But at the same time, it feels like such a waste of time to reassemble a dead laptop. I try to reassemble using the minimum amount of screws, just in case I have to take it apart again. But by the time you've actually gone to the trouble of connecting everything up and plugging it all in for a fair test, you may as well just put in the last couple of screws. Especially considering this is missing a couple anyway. So we're going no guts, no glory now. Let's have a battery as well, because why the hell not? Speaker, right. Remember folks, don't look at what's in the laptop, look at what is left on your bench. And the only things that I have left on my bench are the case screws and the spare DC inboard that I was testing with. Alright. Because if there's nothing left on your bench, then you must have put it all in the laptop, right? Bam. Green light. Charge. And chime. Huh. I think it power cycled. There it goes. Right. Lovely. We have a working laptop, everyone. There we go. So a bad connection under U5110 was causing the SMC to be stuck in reset mode, which was preventing the laptop from turning on. And reflowing the solder joins on that chip seems to have resolved the issue. I'm going to leave this to one side just to make sure it doesn't cut out, and then I'll give it some reboots and stuff like that. And assuming that there's no problems there, it goes back to the customer. Thank you very much for watching, everyone. As always, my support links are in the description down below for my Patreon, Discord, Twitter, Instagram. And if you enjoyed the video, hit the like button, because that helps me out and it tells YouTube that this is the kind of content that you want to see. So YouTube will send you more of these videos. Thank you and see you next time. Bye.